There are a number of ways we're going to ask for inverse of relations and inverse of functions in problems. The first method might be I just give you a relation and I ask for the inverse. Well, to just find the inverse when I give you a relation this way, you switch the x and y values. When you switch the x and y values, then the negative 1 becomes your input and the 0 becomes your output. Here, this 2 maps to the output 2 for the inverse, and the 0 maps to the input. So you simply literally switch your x's and y's. When you graph them, this is always really interesting. When you graph an inverse, it reflects across this line x equals y. So let me graph these points right here, 0, negative 1. So when x is 0, y is negative 1. When x is 2, y is 0. When x is 3, y is 2. And when x is 4, 1, 2, 3, 4, y is 3. Now, let me switch my pen colors here. Let me do my relation in green. So the relation is negative 1, 0. So negative 1, 0. You can see that corresponds, that reflects across this line y equals x of the original point, which is 0, negative 1. Now, 0, 2 is going to be right here. And you see again, it reflects across the line y equals x. 2, 3, 2, 2, 3 is right here. And again, it's hard to see because they're so close. It reflects across the line y equals x. And then 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay. All right. So a function or a relation and its inverse will always reflect across this line y equals x. Now the steps for finding an inverse are straightforward. The first thing you want to do is switch your x and y, solve for y, replace y with f inverse, and then restrict the domain if needed. So suppose I have f of x is minus 4/3 x plus 4. To find the inverse, I'm going to first of all replace the f of x with y. So y is minus 4/3 x plus 4. Sometimes that's a preliminary step. So step 1, we switch x and y. So x is equal to minus 4/3 y plus 4. The second step is you solve for y. So I'm going to subtract 4 from both sides. So x minus 4 is minus 4/3 y. So to get rid of the minus 4/3, I'm going to multiply by minus 3/4 on both sides. And then I'm going to move this y over here because I like it there. So those are going to cancel. So y is minus 3/4 x. I'm going to distribute this. So this is minus 4 times minus 3/4. So this is minus 3/4 x plus 3. The last step is to replace the y with f inverse. So the inverse here, f inverse of x is equal to minus 3/4 x plus 3. Now if I graph these, I see that what I'm going to do is I'm going to do them in two different colors here. When x is 0, y is 4. So 1, 2, 3, 4. And when y is 4, when x is 3, 1, 2, 3. You could have also done slope there. Now, I'm going to come, and I've already kind of created a nice line. Anyone in my class knows that my lines are not straight very often. So this is my original function. Is that lined up there? Yeah, pretty close. Now, let's switch over and do the inverse function, and I'm going to do the inverse function in green. The inverse function is 0. When x is 0, y is 3. 3. And when x is 4, y is 0. So these look kind of interesting. Now I'm going to come down and grab my pre-made line. Here we go. And you'll see if you fold these over this line y equals x, they will line up. What about f of x is equal to x squared? What does this function look like when it's an inverse? Well, let's see. Let's let y equals x squared. Now I need to switch my x and y. So x is equal to y squared. Now I need to solve for y. Now this is interesting. If y squared is x, y is plus or minus the square root of x. Now this is one of those situations where we talk about needing to restrict the domain. So if I let, obviously in this case, I want y to be positive. So up here, if I only let x be greater than or equal to 0, then when I do this switch, and this is pretty common, this will be positive square root of x. So we're going to restrict the domain. Okay, so f inverse is the square root of x with x greater than or equal to 0. Now, what does this look like? Y equals x squared is a parabola that has, let's see, it goes through 0, 0, and then 1, 1. And then when x is 2, y is 4. 1, 2, 3, 4. Did I do that right? 1, 2, 3, 4. Yeah. So y equals x squared is going to look like this. All right, we're going to have some symmetry here. But I want to ignore this branch right here so that I will be able to do the inverse. F inverse, I'm going to do in green here, is y is the square root of x. And y is the square root of x goes like this. That's actually smooth there.